Okay, so if you watched my last video, then you know that I got a little bit stuck with my calculus. I was looking at this sign here and I didn't even know what it was. I thought it might have been the summation sign, but I remember now that that's like an E. So this is, after some Googling, I found out this was the integral sign. And I still kind of didn't really get it. I mean, it's kind of like, I get the whole rectangle under a line area thing, but yeah, I kind of imagine that that's what they're going for, like adding up or like, I don't know. It doesn't, yeah. Anyways, it doesn't really matter. Why? Because if I had just carried on reading, there's this wonderful sentence here which I absolutely adore. So let's just read this bit. Notice that the RMS voltage and current depend only on the peak voltage or current. They are independent of time or frequency. Here are the important relations without the scary calculus. Love it. Absolutely love it. And when I'm looking at it here, I kind of get, so we got the voltage root mean square value, right? And that's equal to blah, bunch of calculus, right? Some integral, some d stuff, whatever, is equal to 1 over the square root of 2 times the peak voltage. Okay. And so that's equal, all of this blah jargon means that, so I can just write this here. I think I've already written this here. Let me just delete it, right? So all of this means that the voltage RMS value is equal to 0.707 times the peak voltage. And that's it. So I need to probably, for my own, because it's not really possible for me to go back and start studying maths from a foundational level, you know, from, I'd probably have to start from like maybe 12-year-old maths or something and work my way up. It's just going to take too long. Like, it's probably going to be, 3 months of a couple of hours a day. I don't have that kind of time. So I'm kind of just going to have to try and wedge in as much kind of memorization and as much, well, just take the equation and don't worry about how you got there kind of thing. Because I get that, lecturers always want to show you, oh, this is how you derive it. But if I just get to, give me the final equation, let me memorize that. And then if I get a question on my exam that says, well, how did you come to this equation? I'll just say, skip that one, sorry. And it is what it is. And yeah, it's not the best, I get it. But like I said, I just, ideally I should have spent my entire summer building up my foundation of maths. But again, who wants to do that when it's 28 degrees outside and you're just going to sit down and add fractions together, multiply fractions? Stuff. Anyways, let's crack on. So, voltage RMS is 0.707 times the voltage peak. And I get that. I actually understand that. And it's the same for the current. The current RMS is equal to 0.707 times the current peak. Okay, and I'm okay with that. All right, so in the previous video, we did the power average is equal to the power peak divided by 2. Okay, and then now the part without the scary calculus bit is that the inverse. So if we're gonna do, let me do it and let's make this a bit neater. So make it smaller. Go over here, and then we'll give voltage the current red, the color red, and we'll give current the color blue. Right? Probably fitting. Meetings, and then let's do now to work out the peak voltage. Obviously, just a bit of algebra. The peak voltage is going to be equal to the voltage RMS divided by 0.707. Is that right? And then what they've got here is basically, I assume it's the inverse of 0.707, which is 1.414. So instead of doing that, you basically just do the peak voltage is equal to the voltage RMS times 1.414. And then you do the same here for current. So the peak If you had the voltage RMS or the current the current RMS, then you can work out the peak by just multiplying it by 1.414. I'm pretty sure, and let's use the calculator. I'm pretty sure that multiplying by 1.414 is the same as dividing by 0.707. And don't ask me how that works because I don't get it. So let's say, okay, we had a voltage peak of, sorry, no, okay, no. Let's say we had a voltage RMS. So we had an average or whatever voltage from a DC supply of, let's go 12 volts. Times that by 1.414. And that means that the peak voltage is 16.968 volts. That's the peak voltage, right? So you could also do 12 volts divided by 0.707, and it's almost exactly the same. I assume there's some rounding done here with the 0.707 and the 1.414. But anyway, so times in by 1.414 gave me this, and dividing by 0.707 gives me 16.973. So close enough, right? So yeah, they're the same. Okay, I'm right with that. So actually, what I like to do is if there's a formula and equation that I really should memorize, I like to put it in an orange box. This is just like my own notation kind of thing that I do for myself. Okay. So for example, US Electric utility provides your home with 60 hertz, 128 VAC. Oh, voltage alternating current. Okay, I was like, what's the VAC? In Europe and many other countries, it's 50 hertz and 240 volts. The VAC unit tells you that the supplied voltage is given. Okay, is given in RMS. Oh, I didn't know that. Okay, 240 volts. Of course, yeah, because it's AC voltage coming into your house, so it's not DC. Never really thought of it like that, to be honest. Okay, so let's put 60 hertz. Oh wait, 50 hertz. Go 50. Get used to 50 hertz. I don't ever plan on living in America. I know some other countries around the world. 60 hertz, 240 volts. 60 hertz, 240 volts. Means 240 volts RMS. Base. Okay. The VAC. Okay. Where am I? If you were to attach an oscilloscope to the outlet, bloody hell, man. I wonder if somebody's done that. There's Electro Beam on YouTube, brilliant guy, and I've seen him test outlets, and he's almost always shocks himself. I know, I assume he does it on purpose. Probably knows how to not shock himself, but it's hilarious. Ooh, excuse me. Okay, so if you were to okay, the displayed waveform on the screen would resemble the following function: the voltage cross time is equal to. So why are we doing 170 volts? Okay, because 170 volts is the peak voltage, and this is in America. Interesting. So I could actually work out peak voltage of UK, right? So we've got 240 volts, and I times that by, let's see if I can remember. Oh, so to work out voltage peak, it's going to be equal to the work out voltage peak is going to be equal to the voltage RMS times 1.414. I mean, it's only one of two options really for me to guess. So it must be, yeah. Of course, it's times 1.414 because the voltage peak is always going to be larger than the RMS value. So when if you times by two, you're obviously getting a larger number, right? If you times by 1.4, you're still getting larger than one times the thing. So then we can work it out. Ah, this is good. This is good. I'm liking it. This is where I enjoy maths. I enjoy maths when I can actually apply it to something, especially something I'm interested in. So times 1.414. Wow. 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 339.36 volts. That's crazy. Let's see if this is true, right? So can I type, let's do peak voltage AC wall outlet. AC wall outlet UK. Hmm. Yeah, it says here for UK mains, the peak voltage is around 330 volts. That's so cool, man. I'm very happy with that. Very, very happy with that. Okay, feel confident with that. So with our new RMS values for voltage and current, we can now substitute them into Ohm's law to get what is called AC Ohm's law. Interesting. AC Ohm's law. So that is voltage RMS is equal to, oh yeah, just basically Ohm's law. So voltage RMS is equal to IRMS times resistance. That's cool. Again, super happy with that. Likewise, we can use the RMS voltage and current and substitute them into Ohm's power law, so P equals IV, to get what's called the AC power law. Nice. So AC power law. So that's just going to be P is equal to IRMS, right? Times VRMS. I'm not looking, so this could be wrong. IRMS times VRMS, yeah. So we then just substitute in V divided by R is equal to I. Then that gives you P is equal to, why do we like substituting in removing current? Or are we just doing the different equations? Okay, got it. So P is equal to V squared RMS divided by R. And P is also equal to I squared. So this is just the power law manipulation, right? I squared RMS times R. Thick. Oh, I feel good. I feel good. Um, okay. I'm gonna try and keep these videos a bit shorter, so I'm gonna end this one here. Just at the moment, I'm in the process of doing a 4K editing PC build, and so at the moment I'm exporting on my laptop, and it takes forever to export an hour-long video, and just makes my laptop unusable. So I'm gonna end this one here, and we'll pick up from here on the next one. I'm feeling good though. I'm feeling very, very good. I'm excited. This is good news, guys. This is good news. I'm actually understanding. When I first sat in my first lecture 2 weeks ago now, I wanted to just cry. I was like, "What is this? This is not even English," and I'm feeling a lot better now. So yeah, man. It took a few hours, but we're getting there. So I shall see you guys in the next one. Thanks for watching. Peace.